doing today. Okay, so I'm going to refer back to the other two pieces of information that I was given. And I asked a lot of you this yesterday. If you look at your diagram, if I know B is the midpoint of AC, what does that tell me? If I know B is the midpoint, what does that tell me? That AB is equal to BC. So if I have one line here, I know those two are the same because I'm told B is the midpoint. So that I can put that on this line. If I know B is the midpoint, I know AB is equal to BC. And then I can make a similar conclusion. I'm given E is the midpoint of DF. So I already have a line here for DE. I know DE and EF then are equal. Okay, and that is by the midpoint theorem. So it's saying I'm going to take what I'm given. So both of these lines then are used to make these conclusions. If you want to draw the arrows so you can kind of see when you have a proof, how am I using what I have to make more conclusions. Then here's for D and E. I just give you the reasons, but now these three lines under B and C, these three lines, you're kind of using these or manipulating them to make these conclusions. So I'm saying that I can now say that BC is equal to DE, which by your diagram, how you have it labeled makes sense, but you have to have a reason why that's true, because you can see you have them marked as being the same. So if I look back at these three lines, I know that in this line, BC is equal to AB, and then in this line, AB is also equal to DE. So if you have two things that are equal to the same quantity, they must be equal to each other. Which property is that? That's transitive. So D is the transitive property. If you just put transitive, that's okay, or a transitive property. You have two segments are equal to the same segment. They must be equal to each other then. Okay, similar for BC equals EF. So I kind of use these two lines to make this conclusion. So I'm going to look at this line I haven't used yet, along with this line I haven't used. So I have EF is equal to DE. BC is also equal to DE. If these are both equal to DE, they must be equal to each other. That's also transitive. So every statement you make in a proof is going to be used to help you make another conclusion. So notice I'm always referring back to what I've stated already or back to what I was given to keep making conclusions. That's the idea. And it does take practice to get used to doing that. So now your last statement is always what you're trying to prove. So you never really have to think about what to put here. It's always what you're trying to prove. So I'm trying to prove that segment BC is congruent to segment EF. And that's actually why both of these are blank. It's not that I didn't give one to you, it's for you to recognize that what you're trying to prove always goes there. I have to come up with a reason though. So now I have to look back at this line E. I haven't used it for anything yet. So if I know BC equals EF, therefore I can say the segment BC is congruent to EF. Why? If I know the measures are equal, I know they're congruent. What tells me that? Angela? Yeah, that's also definition of congruent segments. It's just kind of backwards from when we used it up here. So this is giving you the measures are equal, so the segments are congruent. It's just the reverse, but that's definition of congruent segments. So definition of something being congruent is always, if you know they're congruent, you know the measures are equal, or vice versa. If you know the measures are equal, you know they're congruent. So I know it might seem like you're just stating the same thing, but it is a definition. That's the reason. Okay, so that's number one. And a lot of you, I helped you with that in class, but when I walked around, not everybody had number one filled in. So I do want to go through number two together. And then I'm going to have you look at the reverse side. I know some of you have it done. Not everybody had it done, but maybe after going through number one, now number two will help you to try the back. So if we look at number two, we're given that C is the midpoint of segment BD and segment AE. And then notice, okay, I have a segment here, nothing's labeled on it. So if you don't have a sketch, make one. So if C is the midpoint of BD, I'm going to put point C on here, and it's in between B and D. So I'll put B and D on either side. Okay, but C is also the midpoint of AE. So that means I would also have points A and E on the other ends, and C is the midpoint of that long segment as well. So you have 5 points on that same line, A, B, C, D, E. And we're trying to prove that this segment AB is equal to this segment DE. We want to prove that those are equal. That's our end goal. We have to come up with how to do that, but I've helped you out. Some of the statements, some of the reasons are filled in. So the first one's already filled in, what we're given. C is the midpoint of segment BD and segment AE. So now notice the second statement, we're going to use what we're given. So if you know C is the midpoint, it's kind of like we set up here. If you know you have a midpoint, you know you have congruent segments. So it's saying we know then that BC and CD are equal. And what else would we know is equal? If C is the midpoint of AE, what could we also say is equal? Angela? Yes, AC is equal to EC or CE. If you said EC, that's fine. It's the same thing. What reason is that? What reason did we use? I feel like I'm hearing whisperings of it. It's okay. It's okay if you say something and it's wrong. Proofs are going to be a productive struggle. You are going to say wrong things and have to correct it. That is fine. Wrong answers are fine. Gabe? Midpoint theorem. So do not, like if somebody says something and it's not correct, not that you guys have done this, but don't like fault anybody for saying something and it being wrong. And then if you say something and it's wrong, I know it's hard to not be embarrassed by it, but don't be. That's going to be what this is. You're going to say wrong things, and that's okay. That's how you learn, is you say wrong things and you correct it. That's just part of learning. You're not going to get everything right the very first time. Okay, so that's midpoint theorem. So anytime you're dealing with having a midpoint and saying things are congruent or equal, that's midpoint theorem. Now look at 3. So this 3 is coming up with the reason may have been difficult if you didn't have a picture to look at. So it's saying AC is equal to AB plus BC. And then CE is equal to CD plus DE. What reasoning would go there? And look at your packets if you need to, your property packets. What are we doing to come up with those equations? Segment addition. Yes, we're adding segments to equal a full segment. So that's segment addition. It's a postulate. Segment addition postulate. Now the next line might have been a little tough. So those of you that have this already filled in, kind of and you feel free to state what you thought it was. Perhaps it was right. So line 4, and again, we usually go back to given information. What we have for the reason for line 4 kind of resembles what we have in line 3, but it's not exactly the same. So we have AB, and you can look at your picture too. AB is equal to AC minus BC. Okay, looking at the picture, that should make sense. AB is AC minus BC. And it kind of looks like this equation, but it's rearranged a little bit. So what I want you to think about is from this equation to this one, what would you have to do to that equation to make it look like this? So algebraically, what would you have to do? Subtraction property of equality. So you would have had to subtract BC from both sides to make it look like this, or to solve for AB. So this is the subtraction property of equality. All right, and then 5, I've helped you out in a way by giving you the reason you're going to be using substitution, meaning substitution always comes from looking at things you've already stated and substituting quantities that are equal into something else. So, and chances are you're going to be using line 4. So if I look at line 4, I haven't used line 2 for anything yet. And if I stated this, it means I'm going to use it for something. I haven't used it yet. So if I look at line 4, I know that AC is equal to CE, meaning I can substitute that in. I also know that BC is equal to CD, so I can substitute that in. So therefore, I can say that I'm going to keep AB there, but I can say AB is equal to CE minus CD by using substitution. And now I've used line 2. So always, like I said, I'm going to keep repeating myself. Keep in mind when you're doing proofs, if you state something, you're stating it for a reason, you're going to use it later on. So look back at the lines you stated. If you've not used it for anything, chances are you need to. So I've now used line 2. Then if we look at line 6 is actually very similar to line 4. I've only used part of line 3. I didn't use the second equation. So this is saying DE is CE minus CD. So that's very similar to line 4. You're taking this equation from line 3 and rearranging it by the same reason. You're using the subtraction property of equality to rearrange that equation. Okay, what should go for line 7 for the statement? Angela? Yep, it's always what you're trying to prove. Okay, AB is equal to DE. We have to think of, though, the reason why we can say that. Look back at your statements. I have not used lines 5 or 6 for anything. I've stated them and I've not used them. So if I look at lines 5 and 6, notice AB and DE are equal to the exact same thing. If they're equal to the same thing, they must equal each other. For what reason? There's actually 2 different reasons I would accept here. Transitive. Did anybody have a different idea? Transitive and one other property are kind of interchangeable. I would also accept, yes, I would accept substitution. because you're really taking, if they're equal to the same thing, it's like you're substituting one of those in place of that quantity that's equal. So transitive and substitution are interchangeable most of the time. Okay, any questions on 2? I'm hoping seeing these helps a little bit. Not saying it's now going to be like, oh yeah, I saw number 2, now it's easy. I'm not saying that. I'm just saying I hope it helps. So here's what I'd like you to do. Flip it over. If you haven't done these, 3 through 5, 6 through 8, those are all like the very first thing you did in this chapter. Those are one-step proofs. You're looking at your property packets, and it's saying what property or theorem or postulate or definition, what allows me to make those conclusions. So that's 6 through 8, or I'm sorry, 3 through 8. And then 9 and 10 are both actual proofs. So I want you to start working on this side if you haven't already. Have it completed if you don't already have it completed. What I'm going to do is I'm going to come around and